Hi everyone, this is Aruna Chame, Assistant Professor, Department of Information Technology, SNS College of Technology. In my lecture series, I'm going to discuss about what is the purpose of using database system and also how we can view the data. So before watching this video, kindly watch my previous video. In this video and in that video, I explained about what do you mean by data, information. These are the major simple terminology required to learn the database management system and its concepts. So now we're going to see about what is the purpose. Purpose is what is the need to use the database system. In previous video itself, I have seen why we are going for what is the need to go for a database system, right? From file processing to the database. So before entering into the thing, first we're going to see the definition of database management system. So we know that it is a collection of related data that can be represented to any of the real world entities. And also by using a DBMS, we can have a set of program for accessing the data. So for accessing the data must be in a convenient and also efficient to use that particular data. For this particular purpose only, we are going for a database management system. So for managing these data, we need the three things. One is to be highly valuable, and your data may be relatively large, and also it can be accessed by a multiple user and its application, because at the same time it must be used by so many more than one person. For that particular reason only we are going for a database system. Nowadays in our modern database, they are using some complex software to manage the large amount of data and collection of data. And also in day-to-day life, database is must touch in everyone aspect of our lives, because in every day, each and every person, those are living in this world, definitely they are dealing with the data. For that only I'm saying data can earn, by using a data we can able to earn million and billions of money. If we having a data, we can able to learn. Because for example, if you're considering Amazon and Flipkart and they are not doing any manufacturing data. They are dealing with the data and they are gaining the profit of so much amount. That is a billion and trillion of our amount. So because they are having so many vendors are associated to them, through that only they are doing this particular thing. So data is very most important part plays in our day-to-day life. So this is a major introduction to the thing before seeing the purpose. And also we have to see what is the applications, where and all we can use the database concept. Means we can able to use it in so many field. Because nowadays as a person, if you're having a mobile phone, smartphone, definitely they are having a data. Is it right? You're storing either audio file, video file, film file. If you're taking photograph with your friend, that is also stored over there. So that is one example for database applications. So in an application, where and all we are using means one enterprise information for sales, account, and human resources information. If you're storing, for that, definitely we need the database application. The next thing is manufacturing sector. Their production, inventory, order, supply, everything we're going to store it. We have the place. For that also we can use the database, and also we can able to use this thing in the banking and financing sector. Universities, colleges, and schools and all, they are using the database application. Airlines, telecommunication sector, mobile-based services, web-based services, all documented system, navigation system. These are the major application where and all we are using a database. So database is one of the place to store the data. For storing this particular data, we are going for any one of the software tool. For that, we have to use some query technology to enter the data in the database, and also we can able to retrieve the data from the database according to the convenient way. And also it may be some person they need in this format, some other person they need only this type of a data. So in their own convenient way, if we want to use the data, and also data must be in consistency state. In these and all the cases only we are going for the database the thing. These are the major applications of a database management system. The next we're going to see about the what is the purpose of using a database system. So first purpose is the data redundancy and inconsistency. So if my data is stored in the multiple place, so if I use the file system, it result to a inconsistent, in duplicate data can be in the in duplicate information can be available in the different files. For example, if I have a 10 files with me, so in the 10 files, if I forget to upload a single file, so definitely it is an inconsistency. This could be avoided by using a database concept. Second thing is for accessing the data. If I want to access the data in a file system, I have to go for any programming language to retrieve my data. Again, for retrieving the data, we're going to store it somewhere. So that also create another file. If I go for the thing, if 10% is required, I have to generate a 10 different files. If I want to do the update of the thing, again, I have to go to update the 10 files. This could be avoided by using a database system. So in a database system, it is a convenient and efficient way to accessing the data. The next thing is a data isolation. This could be avoided by using a database system. So because in a file system, if having a multiple files are generated, it will have a multiple format. But in database, it is a schema architecture. It is a standard architecture. Your structure can be defined. In that only we're going to store the data. The third thing is a integrity problem. Integrity problem means, for example, if your account balance is greater than 0, then only a transaction must be taken place. These type of a constraint, we can't able to set it in the file system. This could be applicable in a database system. Second thing is atomicity of update. So atomicity is nothing but your data must be in a should not have it in the inconsistent state. If it is an inconsistent state, only partially updated in your database. This causes to the failure. So whatever the transaction taken place in the, if you are doing any transaction, definitely it will be must updated in your database systems. So definitely it could be supported in a database system, that is a atomicity of updates. For example, if you want to transfer a fund from one account to the another account, should be happen in both accounts. So in one account, it must be debited. In another account, it must be credited. So this to be verified by using an atomicity for updates. And also the next purpose is the concurrent access by multiple users. So at a time, more than 10 to 15 people can able to access, more than one people can access the system. So that must support the concurrent use. If it is for example, if you are using a file system, the same thing is, I have opened one file, the same file is opened by my friend. What could be happen? Definitely it will be read only to my friend because it is already opened by myself. It could not be opened to my friend. So it will go for a read only memory. This could be avoided by using a database system. The last one is a security problem. So here it is very difficult to provide very hard to provide a security services by using a file system. It could be little bit avoided by using a database system. So the next thing is a level of abstraction. So what is a level? Abstraction is the general hint about the data. So in my data, how it could be stored in? It can be stored in the 3 level, physical level, logical level, and the view level. View level is the application level. So through API, we are generating some information to the user. For that purpose only, we are using a field view level. Physical level, it describes how the record going to be stored. So for example, instruction is my record means instruction is my just instruction. I have to store some instruction, instructor details in the database. So how I can store that particular data? That description going to be deals with the logical level. For example, see here, and the relationship also mentioned over here. Here type instructor is my data table. So in that I'm going to record some data. What type of a record I'm going to use? Their ID, name, department name, salary. So this ID must be a string, name must be a string, salary must be an integer. So this mention can be called it as a logical level. The next thing is in your view level, we're going to hide the data types and all. So what we're going to show to the user, so that only viewed in the view level. So your level of abstraction of the data can be classified into 3 levels: physical level, logical level, and the view level. So this is the overall architecture of the view of data. Physical level, that is overall architecture. In logical level, description of my physical level. And view level, what type of a thing I'm going to hide it, what I'm going to show it to the user, that will be defined in the view level. This is the architecture of a view level. Here, while considering this thing, view of abstraction and all, we're going to deal with the two terminology. One is an instance, another one is a schemas. First, we're going to see the schema. So this both the thing is very much similar to the types of variable in programming language. How the value can be assigned to a variable in a programming language, that going to be deals with the schema. So your schema can be classified into two types. One is a logical schema, another one is a physical schema. So the overall logical structure, inner structure of a database, that could be defined by a logical schema. So the overall physical structure can be deal with the physical schema. For example, in the logical schema, the database consists of some information and the set of customers and their accounts in the bank. This is the relationship between these two things. If I do anything, so how my data can be stored, or how my accounts can be stored. This could be deals with the logical schema. So how I can able to connection between the customer and the account entity, that could be deal with the logical schema. This overall structure, how it could be, that can be called it as a physical schema. Instance is nothing but the, at the particular time, what is the actual content present in the schema, that can be called it as a instance. And also one more thing is the physical data independence. This is a very much needed one. So if I do in later as a database architect, I have to modify my physical schema, means without, if it could be changed without changing the logical schema. That concept only we can call it as a physical data. And so whatever the thing I can able to, if I do any changes in the physical schema, that should not be affected the logical schema. So because if I will go for while implementing a query, while converting the ER diagram to a table and all, definitely this concept must be supported. If I do some changes in my overall architecture, that should not be affected my inner logic of the data. So this can be called it as an instant and the schemas. So in my next session, we're going to discuss about the data model and what are the different types of data models, that we're going to discuss in my later section. Thank you for watching my video.